I'm Dean for the Foster College of Business and the Caterpillar College of Engineering and Technology. Welcome to our 2026 annual McCord Lecture. This wonderful tradition began in 1991 thanks to a generous gift from the Illinois Mutual Insurance Company. Jack Lowry, chairman of Hardee's restaurant chain, was the inaugural speaker. This afternoon, we continue that great tradition with the 48th McCord Lecturer, Karel Janeček. We're excited to welcome Karel back to the Hilltop. He's an alum of Bradley University, earning his MBA in finance in 1997. And Karel, I actually joined Bradley that year, so that same year. Karel has an extensive and diverse list of accomplishments, including working as a mathematician, an entrepreneur, and anti-corruption campaigner. Thank you for being here with us today, Karel. I just also had to add that I saw the yearbook here where Karel was playing volleyball, and so I want to extend an invitation to you to come back in the last week of February, not yet, and join our faculty team, which plays volleyball against the students. We're looking forward to your remarks. This lectureship is named for Robert McCord, an outstanding businessman who served as chairman and CEO of Illinois Mutual from 1963 until his retirement in 1990. He was also a dedicated community leader and one of Bradley's dearest and most generous friends. Robert served on the university's Board of Trustees from 1986 to 1992 and was its chairman from 1991 to 1992. Today, we are privileged to once again have in attendance Robert's granddaughter, Katie McCord Jenkins, president of Illinois Mutual Insurance. Katie, would you please stand and be recognized? Katie earned a bachelor's degree from Boston University and a master's in business administration in 2008 from Bradley, where she was recognized by our faculty as the outstanding EMBA Student of the Year. Katie was inducted into Bradley's Centurion Society in 2022. This is the highest honor the university awards its alumni. She has dedicated her career to Illinois Mutual, carrying on a strong family tradition and ensuring one of Central Illinois' best-known companies remains a leading innovator in the field. Katie, thank you for joining us this afternoon, along with others from Illinois Mutual Company. It now gives me great pleasure to introduce our leader and the 13th president of Bradley University, President Jim Shadid.
Thank you, Chris, and thank you for your leadership as Dean of the School of the Schools of Business and Schools of Engineering. As well, members of the Foster College in advancement to pull this off. This is really, really something. I would say it's a sold-out house, but not exactly, since none of you had to buy a ticket to come here and have lunch. Good afternoon, everyone. It is a pleasure to welcome you to Bradley University and to one of the traditions that best captures who we are as an institution, the McCord Lecture Series. You will be introduced to our distinguished speaker here in a few moments. Before that, I wish to introduce the chairman of the Bradley University Board of Trustees, Mr. John Michael. John. As you are all well aware, John also served as the interim president of this university for nearly a year. And at a time when solid, steady, calm, and authentic leadership was required, John Michael provided it. John's commitment to Bradley and to this community exemplifies the leadership of the McCord Lecture Series. Thank you, John. With that in mind, let me turn to why we gather today and begin where this afternoon truly begins, with the McCord family. I would like to introduce to you Kay McCord, wife of Michael McCord. Kay, stand up. And you were just introduced to Katie McCord Jenkins, daughter of Mike and president of Illinois Mutual. And Scott McCord, son of Michael, is here. Scott, thank you. This lecture exists thanks to them. For decades, the McCord name has been synonymous with leadership, service, and an unwavering belief in Bradley University and in this community. Robert McCord set this standard, building success professionally while always investing his time, energy, and heart locally. He believed that strong businesses and strong communities grow together, and Bradley was central to that vision. Mike McCord carried that commitment forward in extraordinary ways, serving, mentoring, showing up, and strengthening the civic fabric of Peoria and the university alike. His leadership was not transactional. It was personal. It was about relationships. It was about making sure that institutions like Bradley thrive for the next generation of young people. And today, that same spirit lives on through Katie McCord, who continues her family's engagement and generosity with the same care and purpose. 3 generations, one consistent belief: when Bradley succeeds, our students succeed, and our whole community benefits. That kind of legacy is rare, and it deserves to be recognized. But what I love most about the McCord story is this: at Bradley University, we do not have to make up hypothetical stories or examples of the impact that our alumni have, not just in this community, but around the world, as you'll hear a little later in the afternoon. We don't have to create case studies or imagine what leadership looks like after graduation. We simply point to families like the McCords and others, real people, real service, real differences made over the decades. The McCord Lecture series is their gift to our students, a bridge between classroom learning and lived leadership, between theory and experience, between aspiration and action. Let me recognize 2 individuals named as McCord Endowed Scholars, made possible by the generous endowment by Illinois Mutual. These professorships recognize professional excellence by faculty in the College of Business, making learning come alive for our students. The Robert A. McCord Endowed Professorship for Executive Management Development was awarded to Dr. Joshua Lear, who also serves as the Department Chair of Economics and Finance, and whose research and teaching has been cited over 2,000 times in academic journals. Where are you, Josh? And he couldn't even get him a seat at the front table. But Candace did. The McCord Endowed Chair of Management and Leadership was awarded to Dr. Candace Eskin. Some of her notable accomplishments in teaching and research include national recognition as one of Keene's Campus Rising Stars for innovation in the classroom. You will hear from Dr. Eskin in a few seconds. Hold on, not yet. 1 second. And it is exactly that bridge that brings us to today's guests. We are honored to welcome Karel Janeček, a proud Bradley alumnus whose journey reflects the same spirit of purpose and possibility. After earning his MBA here, and I'm not going to step on any of your words here, Dr. Janacek went on to become a globally recognized mathematician, entrepreneur, and philanthropist, building success in financial markets and then dedicating significant energy and resources to advancing science, ethical leadership, and democratic institutions around the world. Like the McCords, he reminds us that education is not simply about what we achieve for ourselves, but what we choose to do for others. And that idea traces directly back to our founder, Lydia Moss Bradley, who believed this university should prepare individuals who are independent in thought, industrious in action and pursuit, and committed to serving their communities. The McCord Lecture Series is exactly what she had in mind. Leaders returning to invest in the next generation. So please join me first in thanking the McCord family for their extraordinary and enduring impact on Bradley University and on this community, and then in welcoming Dr. Candace Eskin to the stage to introduce our guest of honor. Thank you, ladies and gentlemen.
Thank you, President Shadid. Good afternoon, everyone. Thank you all for coming today. I'm glad to see so many friends and familiar faces in the crowd. It's obvious that an event like this requires many helping hands. Specifically, today, I would like to thank Matt Riker for his incredible efforts to organize this event. Unfortunately, I do think he's out sick today. But I would also like to recognize another individual, our interim Vice President for Advancement, Charlie Roy, for helping us coordinate Karel's return to campus. Please join me in thanking Matt and Charlie with a round of applause. It is now my distinct privilege to introduce today's distinguished McCord lecturer, Karel Janeček. We are incredibly fortunate to have Karel as a 48th McCord lecturer. He's a one-of-a-kind leader who can speak to the challenges and opportunities of today's world. He was born in Pilsen of the former Czechoslovakia, today known as the Czech Republic. From an early age, Karel was fascinated by numbers. He pursued his passion in mathematics by studying at Charles University's Faculty of Mathematics and Physics, where he specialized in probability theory and mathematical statistics. Karel then became aware of Bradley University after meeting Dr. Arlen Rubash, who later became his close mentor. As you already heard, Karel graduated from Bradley University with his MBA in finance in 1997, and later earned his PhD in financial mathematics at Carnegie Mellon University. One of my favorite stories that I've learned about Karel comes from his time spent right here in Peoria, Illinois. While attending Bradley, his friend told him that it was possible to make money by counting cards in blackjack at casinos. Considering that Karel was only earning about $121 per month from his scholarship at the time, it's easy to see why a college student would be enticed by such a lucrative strategy. So he tried his hand, literally, at the Paradise Casino. Karel also created a simulation software for advantage play in blackjack that he called Statistical Blackjack Analyzer, or SBA, which he started selling to blackjack players. Indeed, Karel became so good at counting cards and consistently winning in casinos that he was ultimately added to the Griffin's Book, an infamous registry of players that casinos ban from playing blackjack on their premises. Now, if you think this story reads like a script straight out of Hollywood, the rest of Karel's achievements are no less dazzling. He has built a career defined by bold ideas and real-world impact. Karel founded the firm RSJ Algorithmic Trading, which quickly became an official market maker on the London Derivatives Exchange, and over time ranked among the highest and largest trading firms in the world, thus turning Mr. Janacek into the Czech Republic's first self-made billionaire, with a B. In an effort to alleviate systemic corruption and redefine democracy among the people, he created the D21 voting method, an innovative system that gives people more nuanced, expressive voting power and is now used in cities, organizations, and institutions worldwide. Karel's passions also extend philanthropically with efforts to generously help those in need. He created the Endowment Fund for Help to build a trustworthy platform to provide aid for those who need it most. After his positive experiences with the Endowment Fund, he later founded the Karel Janeček Foundation, which funds education, science, anti-corruption efforts, and civic engagement initiatives. If all of this weren't enough, just a few years ago, Karel decided he would run for president of the Czech Republic. It's quite a New Year's resolution. Although his bid for president didn't come to fruition, Karel nevertheless was reaffirmed in his efforts to continue making a positive impact on social change. And last but certainly not least, in addition to his many incredible professional achievements, Karel is also a devoted husband and father, something he considers one of the most important areas of focus in his life. Together, these achievements position Karel as a rare figure, someone who moves fluidly between math, money, and societal change, all while leaving a lasting imprint on all three. Ladies and gentlemen, we are very fortunate to have Karel Janeček with us today. Please help me welcome him to the stage.
Thank you. Good afternoon, ladies and gentlemen. Let me thank you so much for this warm welcome back to Bradley University. Thank to Charlie and Jim and others. It was really, I'm so glad to be here. I had a great evening yesterday and have had great day today. And also thank you for the very nice introduction. Yes, it is true. Lecture Blackjack was a very important part of my student life and the software. So now it's over. But now I do other things, and this will be the subject, one of the areas that I focus on, will be subject of today's talk. And it will be about art and mathematics. In fact, I will be speaking about something that I wouldn't believe myself when I was a graduate student here. In fact, until my 34 years old, I was a skeptic. I believe that all we are created, or we just are random evolution. And that changed, and for me it was a total breakup in my philosophy, in my paradigm, when I saw that things are happening not totally randomly, in synchronicities, and I had to totally change my worldview. And there started the journey, part of which I'm happy to share with you. As a maybe first introduction, I will not spend much time on it, but yes, I have been a mathematician from my early childhood. From what I remember, 3-4 years, I loved numbers and math, and the first thing what I remember was so intrigued when I was asking about negative numbers, because I saw the temperature, thermometer, and I was asking my father about what are the negative things. So that I remember as a, 4-year-old kid, and I loved that. And I always continued with my mathematics career, playing games. That's why I was immediately jumped on the blackjack here. But at the same time, I believe that all the things that we are facing are random, which is not totally consistent. But for me, the Occama razor, the most simple explanation of our reality would be that we have unlimited number of trials, and out of this unlimited number of trials, we are the lucky observers that are here. That's, if you know, Stephen Hawking called this spontaneous creation. And then I realized that this is not the case. And I will show you a proof, I dare to say a statistical, mathematical proof what we can find in mathematics. And I will argue why this cannot be by pure random. Meaning that when number 1 was created, there must have been more to it than just pure randomness. And that happened, in like year 2008, 2007, I saw these different synchronicities happening, and as I already have mentioned, it just started to break my belief. And because I studied probability theory, I designed my own test to confirm that myself. So I started a journey of numbers, and because things are not completely random in our creation, I believe. Then I was thinking about what could be a meaning of numbers. There could be some deeper meaning, especially about integer numbers. And that one evening, I had a vision of number 12, or let's say dodecahedron. Right? We have 5 Platonic solids. It's 3D. One of them, perhaps the most interesting one, is dodecahedron, which are 12 pentagons symmetrically around. And I had the vision this one evening that dodecahedron is connected to our rational thinking, that our mind is reflected in this Platonic solid. That was fun. But the next day, I was intrigued because I looked at the internet and I found that according to Plato, dodecahedron represents ether. So the other Platonic solids represents water, air, fire, and so on. So I started to delve into that because it was so interesting, and I could see, I could find so many things about number 12, how it's connected to philosophy, to Christianity, in fact, to also biology and other things. But the more I analyzed that, I was starting to come to number 21, its mirror, as being the special number. Even perhaps in some sense more than 12, or in fact the pair 12 and 21 being so unique. We have that in different aspects of human life, including psychology, for example. You might know that it is being said psychologically that one needs 21 days to get rid of habits, or just to delve into some habits. So now 21 is from many aspects. And also 21 is, I forgot the English term. Anyway, the answer to the question of life, universe, and itself. Hitchhiker's Guide to Galaxy, right? So after 7.5 million years, DeepMind concluded that the answer to the unknown question is 2 times 21. And I say it just made a small error multiplying by 2. Okay. So now, because I figured and I saw the specialty of these numbers. In fact, I encoded that by publicly saying on one conference, I think 2015 in the Czech Republic, that 21 is the number of our universe, being said like in let's say artistic point of view. So so I said that. The reason why I'm stressing is that this is fixed. We have fixed 12 and 21. So all that follows is out of sample. It's not anything re-engineered after we find it. Yeah? So that's important from a statistical point of view. And because I love numbers, and I have already had several foundations, I decided to use the numbers. So my foundation would not give a price of 200,000, but rather would give 21 to the 4th power, 194481. Or instead of 250,000 Czech crowns, it would be 12 to 5th power, which is this 248832. Or nice number, 12 times 21 squared, close to 60,000. So and this is actually I later found it's a good strategy. Unintendedly, but turned out to be a great marketing tool, because people would see, there's a foundation gives a price, and the price is 12 to the 5th power. So then people would say, what does it mean? And they would have to think how to do powers. So there is an education effect, and also there is the effect of attention. So it has this direct good consequences, and even partially educating people. Again, this I am saying up front. It is already given, the strategy of using these numbers. Or times. I would do business meeting not at 2 p.m., but 2:21 or 12:21, things like that. So great. So we have, what I started to use for my foundation and for my life as well, I define aesthetic number, there should be AEs. I'm sorry for anyway, aesthetic numbers, right? And so we have aesthetic numbers 1 to 1, which is the 1221. Also, it's 11 squared. And all these numbers you can see there, right? These are like a first-order aesthetic I define, second-order aesthetic numbers. Why is it? Upfront given aesthetic numbers. 444, a very special one. 777, we'll see in a while. So now let me just one small formula here, just for you to see that we will use later. Imagine that we have that we are drawing a random three-digit number. Yeah. What is the probability that the random three-digit number falls into the category of aesthetics numbers? Right, we had it defined there. So if we have one draw, it would be 7 over 900 because there is 900 three-digit numbers. If we are drawing three random numbers out of the three-digit ones. Yeah. So what is the probability of selecting at least two first order and one second order, or better? Here is the calculation. It is not difficult, but the probability is relatively small. That out of 3 trials, we chose 3 aesthetic numbers. So then 1221, as I said, was fixed as the unique pair. And a few years later, I learned about Sheldon's theorem. Have you heard about Sheldon's theorem, anybody? It is a connection between 1221 and prime numbers. So what we are having here, 21 is mirror of 12, 37 is mirror of 73, and 12th prime is 37, and 21st prime is 73. Okay, so think about it. We have 12, 21, and we have corresponding primes, and the primes, by coincidence perhaps, or not, are 37 and 73. That's called the mirror property. And on top of that, we have 3 times 7 equals 21. That's called product property. And Sheldon's theorem says that this intrinsic connection and feature is unique in a sense that there is no other number in decimal system that would have this property. It was proven in January 2020 by using computers. And this property, the mirror and product, are very, very nice and very special indeed. I can show you our point here. The next first prime greater than 73 that would have the mirror property is this huge number. Yeah, which is where it is palindrome, the prime is palindrome, and also the order of the prime, which is 8 millionth prime, approximately also palindrome. That's why it's the mirror property. It's in fact less nice mirror property than we have here. Here we have different 12 and 21. Yeah? So these are no. And for primes lower than 10 to the 10th power, the only instance other than 17 and 21st prime 73 is this prime 2 million, etc., which has the product property, as you can see there. So both the product and mirror property are very unique. Okay, and indeed for 1221, 3773 is the only in the decimal system that are like that. And now comes well, first of all, what is the likelihood that for a given pair 1221, we have something like Sheldon theorem, connection to the prime, which again was out of sample. It's not something that I found and after came with 1221. It was first 1221 came and then the Sheldon's property. It is absolutely unique. It is great. I do not dare to estimate the probability there because, of course, you can have you have large sample space. You can have different features that you find. But still, the probability is low. It's very special. I am not aware of any other pair of numbers which would have unique properties in mathematics. So it's the Sheldon. But nevertheless, now we have this 3773. So what is the next step? The next step is extending second generation of aesthetic numbers, right, using the 37 and 73. So what did we do before? We did 12 to the fourth power. We did 12 times 21. So obviously the next generation of aesthetic numbers is a product of these combination, 12, 21, 37, 73. And what comes now, how the product looks like. This is the art. This is one of the art coming. So look, we have the square, 12 times 37, 444. The first order aesthetic number. 12 times 73, 876. 8 plus 7 plus 6 is 21. That is the second order aesthetic number. 21 times 37 is 777. First order aesthetic number. 3 times 7, 21. And as I was showing the previous one, the probability of this happening by chance is very low. Now, indeed, here, this is not rigorous because we can hardly claim that we have independent trials. Yeah? So for mathematicians, this is not like a precise statement. It cannot be done precisely, but nevertheless, we are in the order of 1 in million for this being by chance. In fact, the last product, which is not there, 37 times 73, is also very interesting. Yeah, but it's not on the first side, but it is also unique. And by the way, 37 times 73 is also very special. So all the products are special, and the 37 times 73 we can maybe look at the end. So, okay, so we have these products as aesthetic numbers, great coincidence maybe, and another step into searching for aesthetic for art in mathematics, we have 1, 2, 3, and 7, right? 4 digits. What is a 3-digit, very second-generation special aesthetic number? If you go through it a little bit, we don't have that much time here, but you will find out is the number prime, again, 271. Why 271? Because what is missing there? We are missing 3 to the group of Sheldon's theorem. We are missing 3, but 3 is so much beautifully encoded. And 271, look, 3 is 2 plus 1, 21 divided by 7, 7 minus 1 over 2, 2 plus 7, square root of 2 plus 7, and third root of 27. Again, very nice combination. I am not estimating probabilities here, but this is also very special. So we are getting a unique number 271. So now, I will not ask you, but maybe you can think about a question. Imagine two theoretical mathematicians or theoretical physicists who are asked to give you the most important or most special irrational number. Which one would you choose? What would that be? And I am intentionally saying theoretical mathematicians because if you are, for most people, like non-mathematicians, it would probably be pi, right? But you can think of what would you choose. And I mean, this is not the most important, it's not a rigorous question, but there can be done rigorously. Imagine that you have two mathematicians and they get the prize if they choose the same most important irrational number, the most unique. They get the prize, right? So here we have a rigorous question. Now, what would be, anybody wants to share his his irrational number? Or you can write down, you can see well. So I dare to say that it will be irrational number e, right? The base of natural logarithm derivative e to x being e to x. So, and again, here we came systematically, without many trials, systematically to a special 3-digit number 271. This 3-digit number is the first 3 digits of e, probability 1 to 900 approximately, okay? Another step, again, we are continuing with our strategy, with our aesthetics numbers. We define what is aesthetic. Square, of course, of 271. That's the first thing that we would try, the natural operation, like multiplication. What we are getting? 73,441, while 441 is 21 squared. So look at it. We just got, dig out, this is about notation. It is actually not about math at itself, right? It is about notation, about decimal system. So we found 271, and the square is again so unique, we are getting 7321 squared. Probability of that happening, The 73441 is again the aesthetic number of 5-digit. There is less than 42 like these, so probability being again 1 in a few thousand. Now, and most interesting, what is coming now is inverse. If you take a prime number, if you have a large prime number, you take this, its inverse. It will have a period. How long the period will look like? Well, if you have a prime number of size p, the period will be in order of p, maybe average p over 2. There are many prime numbers that have a length of period p minus 1. 1 over p has a period length p minus 1. In fact, under as assumption, it's not rigorously proven, we expect that around 40% of primes, when doing the inverse, have a length of p minus 1. So if you take a number like 271, you would expect that the inverse has a length of period 270 or in this order. Well, for 271, we have this uniqueness, again uniqueness, and in fact my conjecture is that it is in some sense shortest, that 271 is the largest number that has such a short period as 5 of its inverse, and it is 00369. Exceptionally short period. This is something that I could see again, because again, it's a systematic approach. It's not that we have large sample space, trying many things, and in retrospect, confirming what we found. This is all step by step getting there. So when I found this as a mathematician, I was so intrigued and so happy about it. Yeah, and it is new. This 271 is quite new. I found it not so long ago, a few years ago, and I have played with that. And a year ago, I would show this to my friend. This kind of presentation, and I showed him the inverse of 271, and he got completely like, how do you say this? He said, I was like totally shocked. And you can see, actually, by the way, side note, 270, for those who are not that intrigued in inverse, you can see 271 times 369 is 5 nines. Yeah, so it's this is a consequence of the previous 271 to the inverse. My friend was totally baffled by that, and the reason being, here you can see if you type in Google Nikola Tesla number, do you know what you will get? What will step out? It's the number 369. So Google says that 369 is the number that Tesla was obsessed about and stuff. It is probably, it's probably not even true. Yeah, Tesla was obsessed about 9, but not necessarily. There have been stories created how Tesla used different frequencies of 369. Maybe it's not true, but nevertheless, it is a fact that if you in Google Nikola Tesla number, you will get 369. So what is the probability of that, right? Coming, creating this, and then coming back in loop, connecting to Nikola. I don't know. To me, this is amazing, fascinating, and it is what it shows. Again, this was not a huge number of trials, trying million things. He would have done billions of things. And through it's called apophenia, that people find relations among numbers and things which are not there because they are using many trials, and that's how they get there. But no, this was a step-by-step logical approach with no cheating, so to speak, no statistical cheating. And so here I can say a theorem that the probability of, I define actually a random creation. Random creation being that we appeared randomly, and random creation means that all the things that we see our reality are subject to, let's say, physical laws, right? If you have a dice and it is unbiased, you roll it, each number will fall with probability 1/6, or dodecahedron will each number roll with probability 1/12. And if appearance here was supposed to be random, then the things that we observe would have to satisfy law of large numbers and all the mathematical properties. So, and from what I showed you, using only the explicit parts of calculation, I didn't estimate the probability of Sheldon's theorem. I didn't estimate the connection 271 times 369. Even without that, the probability is is in the order of 10 to minus 15. In fact, it would be even lower if we consider the other features. So, to me, this is it would have been an eye-opener to me. If 30 years ago, when I was here, it would really click my mind. I said, oh, my philosophy is wrong because this cannot be by chance. So I am happy to present it to as many people. Maybe it might help somebody to in this process of, because I believe that it is important for each of us to have like own life philosophy, own meaning of life, and search for that, actually. Search for the things that make sense and that we can create and also support each other as people, as on the planet Earth. So here are the wrap-up, what I just talked about, right? It's these nice properties that are there, that are artistic, or it's a signature as I wrote it, and I really love it because it's just special. It's beautiful. I believe that for our world, the kind of something uniting us is things that make sense and that are beautiful. Right? We are in this evolution where we are on a balance between total chaos. Total chaos would be wrong. We would just get dissolved. Or rigorous, precise rules, which could be too much, right? We do not want to have precise rules only. We want to have some space for art, for extension. So our life is like, to me, it's a balance. It's finding the right balance between randomness, between chaos, and between order and logic. So. Yeah, so here is an example of how mathematics, which is a fixed thing, it's a given, it is independent of any philosophy. It is not a religious book which people write, which is open to skepticism. These are numbers that anybody can verify and nobody can dispute. So these numbers, which is the rigorous, precise part, how it's connected to the, let's say, abstract, artistic part of our existence. And by the way, the 37 times 73, I mentioned also this interesting, look, the 271 is again there. We just need to, usually if you can, there is zero, so it's there. And all this is, all this art comes from the fact that we are using decimal system, right? It wouldn't, the Sheldon's theorem is base dependent. It is because of our base, 10 base system. Why 10 fingers then? My conjecture in that is that if we, and I'm sure we make it, we make our evolution will be successful in this birth process of planet Earth, which is full of conflict. But we'll make it, and if we make it, and if we manage to connect as human beings and support each other and go further, we will for sure meet other civilization. And my conjecture would be that other beings, intelligent beings in the universe, will also have 10 fingers. Because if we didn't have 10 fingers, we wouldn't use 10 base system. We would probably use whatever. If there was no number of fingers, probably 12 or 6, right? And there would be no Sheldon theorem. Okay. So thank you so much for listening. I'm happy to any questions or discussions or even objections.
That was really fascinating, and there's two of us who are going to be walking around with mics, so if you want to raise your hand, we can come to you with the mic. as a mathematician.
Hello, thank you for the talk. I'm Matt Tim. I teach in the math department here. So, low probability. When a low probability event happens, it never surprises me. Right? Because low probability events happen all the time. And in particular, my favorite example of this, everybody pick a fraction between 0 and 1. Just pick one out of the top of your head. All right, everybody got something in mind? The probability you were going to pick that is 0. All right, so probability 0, but the number you picked, you just picked it. So low probability events just never surprise me. Doesn't mean that there aren't wonderful coincidences in what you're doing, but what you're talking about. So I do think it's interesting. So thank you.
Yeah, thank you. Yeah, I absolutely agree. Of course, the low probability events happen if we have sufficient number of trials, right? So if there is a probability of 1 in a million, and we have a million trials, our probability that it will happen is 1 to e, by the way. Yeah, if you have a probability 1 over n and you have n trials for large n convergent to infinity, the probability that you will make the special case is e2 minus 1. It's 1 over e. It's quite interesting. So, yes. So, but that's why I was stressing. I was stressing at the beginning what was fixed in advance, right? I came to number 12 and 21. And yes, I didn't go into detail how I got to it. For me, it was important. It was fixed, right? So here, all the other things were again out of sample follows of that. So for example, let's say that if you say that we pick a random number between 1 and million. What is the probability that it will be 951,387? Well, it's 1 over million. But once we do that, we make a random choice. It is not special. Each number has the same probability. What would be, and it wouldn't be even special if we make this random choice, and then in retrospect, are finding theories and combination how we could get to that number. Because you can, in backwards induction, we can kind of statistically cheat ourselves to have to find. For example, if we pick a number 2, 4, 6, 8, 10, or whatever the number of digits, then we say, oh, this is very special. Yeah, but this is the statistical problem that we define the uniqueness or the aesthetic after the fact, after choosing it. But here, in what I showed is that the aesthetics was defined up front. So, if I defined aesthetic numbers up to 1 million, and I define them up front, and I said one of the aesthetics numbers is 7777777, yeah, or like 66666, and then I make the choice, and I indeed choose this upfront selected aesthetic number, which might be, which if it was 177777, and I randomly choose that, then it is a very unique thing. This is, so maybe I got, for these numbers, we can do statistical tests. My argument is that, the low probability is after the fact, after I design the experiment and set it up, and then I make the random choice. It is not totally rigorous because we got the products like the 21 times 37, and those are not randomly generated numbers. Yeah, they are in some sense randomly generated for us because we came for it. So this is not completely rigorous. But the argument of having many trials is actually involved in that. We are good at. Yeah. Thank you.
So I'm Professor Amit Sinha from finance. So Matt was from mathematics. Why would finance be behind? You had made a connection that this art in mathematics reinforced your faith, or some words to that effect. Would you elaborate on that?
Reinforced me?
Your faith, your belief in God, and
yeah, actually, Certainly, when this happened, and I didn't know that. This is relatively new, but it was in 2007, and I would design tests more myself. So I would say, okay, and then I could see synchronicities happening, which I cannot share. But it doesn't make sense because everybody can do that, and then it's already subject to random things happening if you have enough trials. But for myself, I could do that, and this was like for me, wow, a total change in my approach to life, and actually it improved it a lot because suddenly life makes much more sense than if it was only random evolution. And yes, so it gave me the trust, I call it trust in the meaningfulness of our being. That's what I strongly believe now, that our being here has a deeper meaning than just random evolution. And I came to that. We can call it belief in universe, God, or something more. Yeah. Thank
you. We're almost running out. This was a fascinating conversation and a wonderful presentation. So let's give a big round of applause to Karel.
Thank you. Thank you. Thank you.
So, I was just so fascinated by a lot of things, especially the 42 and the 21, the Hitchhiker's Guide to the Galaxy. And there's so many wonderful insights that you can get from this. So on behalf of all of us here at Bradley University and the wonderful organization that our friends have done here, I want to thank you. And
thank you so much. And thank you.
I also wanted to remind everyone that I hope that you enjoyed this program, and I want to remind you that next year will be our 49th McCord Lecture, featuring another renowned and inspiring leader from the world of business. Enjoy the day.